Okay, so today we're going to finish up the examples from the notes for section 3. I'm going to start with number 11. So for number 11, notice the directions have changed now. Notice they're telling us to check for extraneous roots. Now, also located up here at the top, now when you go to do your homework tonight, this is the interval that I want you to find your answers on. I want you to find your answers from 0 to 2 pi. Notice the bracket around 0 and the parenthesis around 2 pi. So all this is telling you is you're using the unit circle. Okay, you can include any answers from 0 up into 2 pi, but don't include 2 pi in any of your answers because 2 pi is the stopping point, and notice it's got a parenthesis around it. Now, for this one, these two examples, 11 and 12, notice both of them only have sines and cosines left in them. I can't do anything else to simplify this any further the way it's written. So the technique I'm going to use to solve this, to figure out what angles will satisfy this, is I'm going to square both sides of my equation. We did this when we solved radical equations, and now we're going to do it now to solve this one. So when I go to solve this, I'm going to take the left side, cosine x plus 1, and I'm going to square that binomial. In order to keep things balanced, if I square the left side, I also have to square the right side. Yes? Generally, if you're going to see nothing but cosines and sines left, and they're not a cosine squared or a sine squared, there's not much left to do. Yes?
What do you do if you work out a whole question, your answer doesn't not in the unit circle?
For this one, you're looking at the unit circle to get it. Now, if you get an ordered pair that's not, then it's a calculator question.
Because I got the homework, for some of them I was getting ones that were on the unit circle.
Correct. Then you're going to use a calculator for those. If there's time, I'll show you that. So if it ends up being the answer is not on the unit circle, like let's say it's 3/4, then what you could do, but if you have to square root that, then it becomes something on the unit circle. But let's say it ends up being, I forget which question it is. I'll look for it. I think there might have been one. We'll look at it after we finish the notes. And then maybe I can add it to the notes here and I'll do it. All right, so let's just work on these and then I'll add an example 16 and I'll show you what he's talking about. All right, now, key thing to remember here is when you square a binomial, really what you're doing here is you're taking cosine x plus 1, writing it 2 times, and foiling it. Don't just think you can square cosine and square 1, you miss out on the middle term. So I'm going to do FOIL here. First gives me cosine squared x. Outside gives me cosine x. Inside gives me cosine x. And then finally last gives me 1 times 1 is 1. I can add the red and the blue, and that'll give me 2 cosine x. So once I FOIL this binomial squared, cosine squared x plus 2 cosine x plus 1 equals sine squared x. Now, in order to solve this, I need to get these trig functions to be the same.
Wait, you can move, you can just make it sine squared x? Because before you had a sine x squared. It's the
Right.
same thing?
Yes. So I'm just moving the exponent down here and putting it on sine.
Is there a reason you're doing that?
Because that's what you're used to seeing.
Oh.
Okay, so now I need to get all of the words to be the same. I'm going to use a Pythagorean identity and substitute that in for sine. So the Pythagorean identity I'm going to use is sine squared x plus cosine squared x equals 1. I'm going to solve it for sine. Sine squared x equals 1 minus cosine squared x. This is what I'm going to substitute in for sine on that right side. So let me rewrite the left side. Cosine squared x plus 2 cosine x plus 1 equals 1 minus cosine squared x. I've substituted now. Now I need to set my equation equal to 0, so I'm going to move the cosine squared x over as well as that 1. So first let me move this one. Add cosine squared x to both sides. This becomes 2 cosine squared x plus 2 cosine x plus 1 equals 1. Now I need to move the 1. Notice it cancels from both sides. So now I'm left with 2 cosine squared x plus 2 cosine x equals 0. I'm going to move this up to the top. So I'm just going to rewrite it over here so I have more room to work. Now, this did not turn into a trinomial, but it is a binomial that I can find a greatest common factor for. And my GCF is going to be 2 cosine x. So let me divide both of them by 2 cosine x. After I divide the first term, I'm left with cosine x. And then the second term is anything divided by itself is 1. Now that it's factored, I set each factor equal to 0. So 2 cosine x equals 0. And then what's in the parentheses? The other factor equal to 0. I'm going to solve each one. This one I divide by 2. Cosine x equals 0. The black one I'm going to subtract 1. And cosine x equals -1. Now, once I solve my trig equations and I see that I have a 1 or a -1 or a 0, this tells me, hey, don't look in the quadrants. Look at the ordered pairs from the axis. Look at the x or the y axis. So when I go up here for the blue one, remember cosine looks at x. So I'm going to figure out where x on my unit circle, it has a 0. And you can see that it happens at pi over 2 and at 3 pi over 2. So that's what I get for the blue one. So x equals pi over 2 and x equals 3 pi over 2. I'm looking to see where the x equals 0. At pi, x equals -1. I'm doing the other one now, yes. So now I'm going to do the black one, and yes, you are correct. For the black one, it's going to be x equals pi, because I'm looking to see where x in my ordered pairs equals -1, and it's at pi. Now, the instructions said check for extraneous solutions. In the homework tonight, it does not tell you to check. You need to know which ones to check. And the only ones you need to check are the ones that you're using this technique of squaring both sides in order to solve.
How many are those?
I'm sorry?
How many of those are on
I think at least 3. I'll let you know. All right, so let's take our original equation. Cosine x plus 1 equals sine x. I'm going to use this equation for all 3 when I do the check. So the first one I'm going to check is the pi over 2. So I'm going to take cosine of pi over 2. I'm taking out the x's and replacing them with the angle measures. Plus 1 equals sine pi over 2. I'm going to go ahead and grab that ordered pair for pi over 2. if I come up here to my unit circle, the order pair for pi over 2 is this one, 0, 1. So let me just bring it down here so I don't have to keep going back up and down. So for pi over 2, 0, 1. So remember, cosine uses the x. So cosine of pi over 2 is 0 plus 1. Then the sine of pi over 2 uses the y, and that value is 1. 0 plus 1 is 1. 1 equals 1. This is a good answer. So my first solution that I found, pi over 2, is good.
I'm confused on what you did there.
Okay, so the value of cosine of pi over 2, remember cosine equals the x of the order pair. So the order pair for pi over 2 is this order pair 0, 1. The cosine is the x, the sine is the y.
Of the same word. Oh, and then you just filled it in.
Yes. All right, so let's keep going. Now I'm going to check. So this one was good. Now I have to do the check for 3 pi over 2. So now I'm going to use the same equation. Cosine 3 pi over 2 plus 1 equals sine 3 pi over 2. The order pair for 3 pi over 2 is the order pair 0, -1. Cosine uses the x plus 1. Sine uses the y. 0 plus 1 is 1. 1 is not equal to -1. So 3 pi over 2 is an extraneous solution. So I will throw this one away. It is not listed as one of my answers. Now I have to check pi. So now I'm going to do cosine pi plus 1 equals sine pi. The order pair associated with pi is -1, 0. Cosine of pi is going to be -1 plus 1. Sine of pi, use the y, it equals 0. -1 plus 1 is 0. 0 equals 0, it checks. So pi is a good answer.
Can you say the percent?
Yep. So the two answers here are pi over 2 and pi. Throw away the 3 pi over 2. We're going to do the same thing on number 12. All right, we're going to square both sides. So we're going to take sine x plus 1, square it. Cosine x, square it. So I'm going to FOIL the binomial squared. This will become sine squared x plus 2 sine x plus 1 equals cosine squared x. My trick for squaring a binomial is I take the first term, square it, take the second term, square it, but my middle term, what I do is I multiply this times 2. Again, some people forget these little tricks, so that's why I always recommend write it 2 times and FOIL it. It never fails. But that's how I always square a binomial, and I can do it in my head. All right, so now
What do? You times the middle two and then,
by 2.
oh, so you did 1 times sine times 2?
Uh-huh.
Okay.
All right, now I need to do a Pythagorean substitution here. Again, I'm going to use the same one I did before. The sine squared x plus cosine squared x equals 1. However, this time I'm solving it for cosine. So I'm going to move sine squared x over. So cosine squared x equals 1 minus sine squared x. I'm going to substitute this for the cosine on the right side. So now I have the left side that's still the same. sine squared x plus 2 sine x plus 1. Replace cosine now with 1 minus sine squared x. I need to set it equal to 0, so I need to move the stuff over to the left side. So I'm going to add sine squared x. This becomes 2 sine squared x plus 2 sine x plus 1 equals 1. Move the 1. Notice it cancels from both sides. And now I have a binomial that I can factor out a GCF. My GCF is going to be 2 sine x. I'm left with sine x plus 1 equals 0. Set each of the factors equal to 0. So 2 sine x equals 0. And then sine x plus 1 equals 0. This factor as well. Solve the blue one. Divide by 2. Sine x equals 0. Solve the red one by subtracting 1. And now this is where I use my unit circle. So remember, sine looks at y. So I'm going to go to the unit circle, figure out where there is a 0 in the y of the ordered pair. So up here at my unit circle, I have one here at 0 and also at pi. So for the blue, x equals 0, x equals pi. For the red one, I'm looking to see where the ordered pair has a y that equals -1, and that's at 3 pi over 2. So x equals 3 pi over 2. Because I use the technique of squaring both sides, I need to check for extraneous solutions. I'm going to take my original problem. My original problem is sine x plus 1 equals cosine x. So let's plug in 0 first. So sine of 0 plus 1 equals cosine 0. I'm going to grab the ordered pair for 0, and that's going to be the ordered pair 1, 0. Sine uses the y, cosine uses the x. 0 plus 1 is 1, 1 equals 1. The answer of x equals 0 is good. Now let's check pi. Sine of pi plus 1 equals cosine of pi. Order pair associated with pi is -1, 0. I'm going to plug in the 0 for the sine. So I get 0 plus 1. Cosine uses the x. 0 plus 1 is 1. 1 is not equal to -1. So this is gone. This is an extraneous solution. So get rid of the pi. Let's test out the 3 pi over 2. Sine 3 pi over 2 plus 1 equals cosine 3 pi over 2. Order pair associated with 3 pi over 2 is 0, -1. Sine uses the y. Cosine uses the x. -1 plus 1 is 0. This one checks. So I have another good answer. So 0 and 3 pi over 2 are the two solutions here. Okay, so far I've solved it just like I've done before. I'm ignoring right now for the moment that this is a 3t. I move the 1 by adding it to both sides, then I divide it by 2, and now I am looking at my unit circle in quadrants 1 and 4 to figure out where the x of the ordered pair equals 1/2.
You circle A and C for looking where cosine's positive, right?
Yes. So now I'm going to come up here. I'm looking to see where x equals 1/2, and I can see that that happens at pi over 3 and at 5 pi over 3. So those are my two answers so far. Now remember, before we would just put x equals those two angles. But now instead of x here, I've got 3t equals pi over 3 and 3t equals 5 pi over 3. Here's where we use the number that's in front of the variable. Normally, if we had something like this, 3x equals 9, you know you divide by 3. We're doing the same thing here. We're going to divide both sides of our equation by 3. Same thing here. So all we're doing for this one, think of this as pi over 3 divided by 3. Keep, flip, change it. Pi over 3 times 1/3. So t equals pi over 9. Over here, you're going to do the same thing. It's 5 pi over 3 divided by 3. Keep, flip, change it. And it's 5 pi over 9. So the only thing you do with that coefficient in front of your variable is at the end, divide your final answer, your angle, by it. So the two answers here are t equals pi over 9 and t equals 5 pi over 9. Now, if this were now this is how you would give your answer on the test next week, but if this were on a standardized test, remember for sine and cosine, we add 2n pi, but we would also divide that 2n pi by the 3. Again, for our testing purposes, we don't need to do this. Your two answers are just going to be the part that's in front of that 2n pi. Just know that I'm sorry? You don't have to add that to the homework, no. So just know that all that's doing is telling us that there is an infinite number of solutions that we can find for this problem just by continually adding 2 pi. Let's try the next one. I'm going to add the square root of 3 to both sides. I get 2 sine 2t equals root 3. Divide by 2. And sine 2t equals square root of 3 over 2.
Wait, we didn't have to check the other one? We only check it?
Only when you square both sides.
Oh, okay.
Now, for sine, remember we look at y. Let's go ahead and narrow down which quadrants we're looking for a y to be root 3 over 2. All students take calculus. Sine is positive in quadrants 1 and 2. So I'm going to come up to my unit circle. I'm looking for an ordered pair that has square root of 3 over 2 in the y spot.
Wait, is it not plus and minus, so isn't it all 4?
No, because I did not square root it to solve. You only get all plus minus when you're square rooting both sides. So I'm going to come down here, or up here, sorry, and find where I have square root of 3 over 3, and I already have it at pi over 3, and then the other one is at 2 pi over 3. So these are my two angles where the y of the ordered pair is square root 3 over 2. So let me go ahead and write that down. So here, 2t equals pi over 3. 2t equals 2 pi over 3. Again, I need to divide both sides by 2. And this becomes t is equal to pi over 6. And here, pi over 3. If it's easier for you to think, I'm going to multiply both sides by 1/2, you can do that as well. Now, if you just can't see how this simplifies, write it out. 2 pi over 3 divided by 2 over 1. Keep flip, change it. See how the 2's cancel, and that's how I got pi over 3. And those are the two solutions. The next one, we're going to be using quadratic formula because it's not factorable. So let's try number 15, last example. And then I'm going to do one where you would use your calculator. This one you're going to use your calculator. So here, this trinomial, if we want to go ahead and look at it as x squared minus 3x minus 2, there are no factors of -2 that will give me -3. If that were a +2, I could factor it. So because this is not factorable, I need to use quadratic formula. Remember, the number in front of x squared, in this case it's a 1, is your a. The number in front of x is your b. And then the constant is going to be your c. The quadratic formula is -b, or opposite of b, plus or minus b squared minus 4 times a times c. All of that is under the radical, divided by 2 times a. I'm now going to go ahead and plug in those numbers. So opposite of b, or negative b, is -3, plus or minus -3 squared minus 4 times a times c, all under the radical, divided by 2 times a. -3 becomes +3. -3 squared is 9. -4 times 1 times -2 is +8. Divided by 2. And now this gives me, now remember when you did this, when it's just without a sign, this was all x equals normally. You were finding the x of your ordered pair. But this is really sine x equals. Sine x equals. So now let me split it apart. I'm going to say that it's sine x equals 3 plus the square root of 17, because I'm going to add the 9 plus 8.
Wait, can you repeat what you said before that?
I'm adding 9 plus 8, and I get 17.
About the sign. You're splitting it into negative and positive.
Correct. I'm splitting apart the plus minus. Now I'm going to actually do the math here on my calculator. I'm going to add 3 plus the square root of 17 divided by 2. Once I do that on my calculator, I end up getting 3.5616. And over here, I get negative 0.5616. Remember, the value of sine must be between -1 and +1. Notice the first one is out of that range. It's too big. This gives me no solution. However, this one is in the range. We're looking for an angle measure. So this is where we use our inverse. So we're going to be on our calculator doing sine -1. Now, remember what we're looking for are angles from the quadrants. From the calculator, we're going to get the reference angle. For quadrant 2, remember you take pi, subtract the reference angle. Here it's pi plus the reference angle, and here is 2 pi minus the reference angle. However, to get the reference angle from quadrant 1, I am going to enter this number as a positive 56.16. This is going to give me 0.5963 is my reference angle. I'm looking for a sign to be negative, because that's what I got here. Sign is negative in this quadrant and in this quadrant. So I'm going to now do pi plus 0.5963, and I get 3.7379. And make sure your calculator is in radians, not degrees when you do this.
Wait, you looked for where sign was negative?
Correct?
Okay.
5.6869. And these are your two answers. Your answers are coming from quadrant 3 and quadrant 4. And that is it for the notes. I'm going to add one problem from the homework where you need to use your calculator as well. Let me go ahead and look to see what number that's going to be. So sometimes, even though you can factor it, it's not going to come from the unit circle, and you would use your calculator. So this is number 8 from the homework. We have 4 tangent squared theta plus 5 tangent theta equals 6. I'm going to move the 6 over so I can set my equation equal to 0. And then I'm going to factor the trinomial. This one you can either do factor by grouping because it's a little bit bigger, or you can guess and test. This factors into 4 tangent theta minus 3 and tangent theta plus 2. I set each of these equal to 0. And then here add 3. 4 tangent theta equals 3. Divide by 4. And this should be, no, that's just tangent theta equals 3/4. Here, subtract 2. Tangent theta equals -2. These are not any values on my unit circle. So I'm going to use my calculator. And you're going to use the inverse because we're looking for an angle. So we would do tangent -1
How do you know when to use calculator?
when it doesn't give you something that's on your unit circle. So tangent of 3/4, tangent -1. Once you do this, you get theta is equal to 0.6435. Over here, you'll do tangent -1 and put the 2 in there. And then here, we would get tangent of 2 is 1.1071. However, we want tangent to be negative. All students, so here, tangent's positive here, but it's negative here. So I need to do pi minus this reference angle. This is the reference angle. So then I'm going to do pi minus 1.1071, and the final answer here is 2.0344.
I thought you drew it where it's negative in 2 places.
But tangent, remember, we're only working with quadrants 1 and 2.
Okay.
So those are your 2 answers. So this is an example from the homework where the answers we got for X are not on the unit circle, so we would need to use our calculator.